There are 5 sections in this module: Introduction to vSphere High Availability, Configuring vSphere High Availability, vSphere High Availability Architecture, Introduction to Fault Tolerance, and Introduction to Replication. vSphere offers protection at every level. It offers protection at the data level with network interface card teaming. It provides protection at the server level with fault tolerance and high availability. It provides protection at the storage level with data replication. It provides security at the data level with the VMware backup software, and the VMware vSite Recovery Manager is used to provide redundancy of data centers. This is the only one that we don't discuss in this class, the Site Recovery Manager. In this chapter, we will focus on protection of the server and protection of the virtual machines. So let's get started on Lesson 1, Introduction to vSphere High Availability. In vSphere High Availability, if an ESXi host dies, the virtual machine startup on another ESXi host, and this requires that both hosts are members of the same cluster. What's a cluster? A cluster is a group of hosts. When you add a host to a cluster, the host's resources become part of the cluster's resources. Go down to the bottom and click on Learn More About Clusters. Using clusters. In the next chapter, we will talk about DRS clusters. But in this chapter, we will talk about vSphere High Availability. vSphere High Availability allows virtual machines running on ESXi hosts to automatically recover from host failures. High availability allows us to recover from host failures. But before we discuss high availability, let's review what does it mean to boot a virtual machine. Well, I think everybody knows what it means to boot a computer. When you turn a computer on, the operating system comes off of the hard disk and is loaded into the RAM of the computer. That's the definition of booting. Well, let's look at booting of a virtual machine. Typically, the virtual machine files are stored on a disk array on a storage area network. So when you boot the virtual machine, the VM files come off of the disk array and are loaded into the RAM of the ESXi host. That's the definition of booting a virtual machine. Now let's turn to high availability. In high availability, in this example, we have 3 ESXi hosts, and there are several virtual machines running on this ESXi host. If the ESXi host crashes, then the virtual machines that were running on the ESXi host on the left will be started on the ESXi host in the middle. How does it do that? Well, the same way it started the virtual machines on the left. The virtual machine files are pulled off the disk array on the storage area network and loaded into the RAM of the second ESXi host. And there's a delay there of maybe 30 seconds or a couple of minutes, depending upon how many virtual machines you have to load. With high availability, if an ESXi host dies, the virtual machines start up on another host. High availability protects against multiple types, 3 different types of failures. Host failure, which we just discussed, but also operating system failure and application failure. If there is a host failure, the virtual machines start up on a different ESXi host. If there's an operating system failure, the virtual machine is restarted on the same host. And if there's an application failure, the virtual machine that application was running on is restarted. Let's look at those 3 examples. The first example, we get a host failure. Here we have 3 ESXi hosts, 2 virtual machines running on each. On the ESXi host on the left, if it crashes, then the virtual machines start up on the other ESXi hosts, assuming, of course, that there is free RAM on those ESXi hosts. That was the first scenario. Second scenario is a guest operating system crashes. So here are 3 ESXi hosts, and in each virtual machine is a guest operating system, and VMware Tools has been installed on that virtual machine, because VMware Tools is what sends the heartbeats between ESXi hosts. If one guest operating system crashes, then the master ESXi host no longer receives the heartbeats. And if that virtual machine has crashed, it is then restarted on the same ESXi host. And then in the third application, the third example, the application crashes. So what we have is an application running on a virtual machine. If the application crashes, high availability restarts the virtual machine, which reloads the virtual machine and reloads the application. High availability protects against 3 types of failures: a failure of an entire computer, a failure of an operating system in a virtual machine, or a failure of an application in an operating system in a virtual machine. Let's now look at configuring vSphere high availability. 2 steps. 1, we create a cluster, and 2, we add the ESXi hosts to the cluster. Log in using the vSphere client to the vCenter server, and I'll go to our data center, right-click, and select New Cluster. I will call the cluster Cluster 1. And I will turn on the vSphere High Availability feature. vSphere High Availability detects failures and provides rapid recovery. I will not click on DRS. We'll do that in the next chapter. Click on Next. Then it says, do we want to enable host monitoring? Well, of course I want to enable host monitoring. That's the whole reason that we have a high availability running. The only reason I would not enable host monitoring, or I would disable host monitoring, is because I am performing maintenance on those ESXi hosts. But typically, almost always, we would enable host monitoring. Then we look at admission control. The vSphere High Availability Admission Control Policy determines the amount of cluster capacity that is reserved for VM failovers. Admission control means if there are not sufficient resources for fault tolerance, then no new virtual machines will start. Here's the example. A virtual machine takes 4 gig of RAM on the host that it runs on. And therefore there must be 4 gig of free RAM on another ESXi host to provide failover if necessary. If there's not 4 gig of free RAM on another host, then that virtual machine will not start. This is admission control. So we do want to enable admission control. I will click on Enable Admission Control. Then the admission control policy allows us to specify the type of policy that admission control should enforce, and I will specify host failures the cluster tolerates and set that to be 1. So what that means is if one entire ESXi host crashes, then the cluster will be able to tolerate that failure, meaning it'll continue to operate. Here's the example. If you have 3 ESXi hosts and 2 of the hosts are already operating, then the 3rd host must be free to provide failover capacity. I mean, you could they don't call it a standby ESXi host, but essentially it means you have an extra ESXi host here in case one of these 2 here crashes. That's what's meant when you set the host failures the cluster tolerates configuration parameter when you set it to 1. Well, you might not have one extra ESXi host lying around. So another alternative would be to select percentage of cluster resources reserved as failover spare capacity. And I will set that to 50%. If I set the admission control policy to 50%, then if an ESXi host crashes, then only 50% of the virtual machines will be covered. For example, if you have 3 hosts and 2 of the hosts are at 50% capacity, then the third host must have 50%, at least 50% free RAM to provide failover capacity. In this case, not all virtual machines will be protected if we set it to be 50%. Only 50% of the virtual machines will be protected. So the question is, which 50%? And this is controlled by the virtual machine restart priority. I will leave that at the default, which is medium, but I will see that we can change it to high or low to change the VM restart priority to make it separate for different virtual machines. We will discuss the host isolation response later, and we can configure the host such that if it is isolated, it can be powered off. Click on Next. Then we set the VM monitoring status. VM monitoring restarts individual virtual machines if their VMware tools heartbeats are not received. If the heartbeats are not received within a set period of time. Monitoring restarts virtual machines if heartbeats are not received within a set period of time. Do I want to enable this? Well, absolutely. That's the reason that I am using high availability, is so the virtual machines will be monitored using heartbeats. We can set the monitoring sensitivity to high, to medium, or to low. What that means is this. If we set it to high, then there will be a quicker response to a failed host. But the disadvantage of that is that this may be triggered due to network latency. In other words, the host didn't fail, the network was just slow. And that's why the heartbeats didn't come through. And what that is called is a false positive. Conversely, if you set it to low, then there's a lower chance of a false positive, but the disadvantage is it'll take longer to respond when a host does fail. At CCBC Catonsville, we have pretty good high-speed network connectivity. We don't have a big problem with latency. So I will set it to high because there is typically not a problem with latency in this network. If there was a problem with latency in your network, then you would set this variable to low, but we'll set it to high. Click on Next. Do we want to enable enhanced vMotion compatibility? We will cover that in the next module. Click on Next. Store the swap file in the same directory as the virtual machine. Well, typically you would. The only reason that you might put the swap file in a different data store is because that's a higher speed data store and you expect a lot of swapping is going to go on. But we hope there will not be a lot of swapping, so we will leave the swap file in the same directory as the virtual machine. We click on Next, we click on Finish, and the cluster has been created. Now the next thing to do is to add the hosts to the clusters. So let's do it. Cluster 1, right-click, select Add Host. And this looks just the same way we added hosts in Chapter 4 when we added hosts to the vCenter server. We type in the IP address of the ESXi host. We type in the username, which is usually root, is the name of the administrator name. We type in the password. Then we click on Next. These are the virtual machines which are running on that ESXi host. Click on Next. We will leave it in evaluation mode, and once we got it all up and running right, then we'll go back and we will enter the license key. For the moment, leave it in evaluation mode. Click on Next. We will not enable lockdown mode. Click on Next. Click on Finish, and we have added one host to the cluster. 4 more to go. Well, another way to add hosts to a cluster is by using drag and drop, because they've already been added to the vCenter server. So I just put my cursor on those hosts, hold the mouse button down, slide it over to the cluster, let it up, and that moves the ESXi host all to that cluster. If I expand that cluster and I click on the Hosts tab, you can now see we have all 5 ESXi hosts in that one cluster. 5 ESXi hosts in one single cluster. If we click on the Summary tab, we can see that high availability is enabled and that the total CPU resources is 42 gigahertz. And what that means is we have 42 1 gigahertz processor, or we have 21 2 gigahertz processor, or we have some sort of a combination of that. You add them all up together, 42 gigahertz. The total memory, all of these ESXi hosts combined, is 67 gig. Total storage of them all combined is 1.3 terabytes. We can see that there are 5 hosts in the cluster, that the admission control policy is enabled. We have, at the moment, right now, we got 99% failover capacity, so that is certainly not a problem. But the minimum failover capacity is set at 50%. Host monitoring is enabled, and virtual machine monitoring is enabled. If we click under cluster status, we will see that there are the heartbeats, and that there is a master host, and that is .13 becomes the master, and the other 4 hosts are connected to the master. Now, we didn't have to configure which was the master. Once we added ESXi hosts to the cluster, they automatically hold an election and create a master, so you don't have to delegate a master. Restart order. Now, we previously said if you set the admission control policy to 50%, that only 50% of the virtual machines will be covered in case the ESXi host crashes. So the question is, which 50%? We go to the cluster and we right-click and we select Edit Settings. We've already turned on vSphere High Availability. If we click on Virtual Machine Options, we can see that the virtual machine restart priority is medium for all of them. Well, I want to make sure that the DNS server starts up before any of the other virtual machines. So if I right-click on the DNS server and select High, it will start up before any of the other virtual machines start up. I want the domain controller to start up before any other virtual machines are up and running. So I will right-click on the domain controller and I will select High. So these 2 virtual machines will start before any of the others will start, because all the others are set to medium. And then if I don't want my web server to come up until all of the other virtual machines are up and running, I could right-click on that web server and I could give that one a lower priority. So the VM restart priority is by default medium for all virtual machines, and you can change it to high or low for specific virtual machines. If you want one virtual machine to boot before the others, you set the restart order. In summary, high availability provides automated failover. You have multiple ESXi hosts. If one ESXi host crashes, then the virtual machines are loaded into the memory of another ESXi host. Now let's look at vSphere High Availability Architecture. Just a minute ago, we clicked on Cluster Status, and we saw something about heartbeats, something about a master host operating. So let's see how that works. Let's look at the vSphere High Availability Architecture, how they communicate with each other. there are multiple hosts in the cluster. In this case, 3 hosts. There's one, there's one, there's one. This is called a fault domain. The fault domain is managed by a master host, and there is the master host right there. When high availability is enabled, the fault domain manager service runs on each host. There it is, and there it is. And vCenter server, that's you or me, sends a list of hosts and protected virtual machines to the master host. And then the master host sends that information to the slave hosts. And the slave hosts monitor the health of the virtual machines. And if one of the virtual machines or ESXi host crashes, the master restarts the virtual machines. So the question is, how does the master know that an ESXi host has crashed? And the answer is heartbeats. The master sends heartbeats to the slaves, and the slaves respond with heartbeats. But what if there is a failed slave host? Well, if the host fails, then it's no longer sending heartbeats. If the host has failed, then the master is no longer receiving heartbeats. And if it doesn't receive heartbeats, then the virtual machines are started on another host. That's the job of the master host. It's not something you need to select. It's something that's automatically selected when we install high availability. But what if the master host fails? If the master host fails, then the slave hosts are no longer receiving heartbeats. So then the slave hosts hold an election. This is not something that you need to do. It's an automated process. And elect a new master, and then the new master sends heartbeats to the slave hosts. In other words, it monitors to make sure that the slave hosts have not crashed. Heartbeats. There are network heartbeats, but there are also data store heartbeats. The purpose of the heartbeat is so the master host knows that the other ESXi hosts have not crashed. A network heartbeat is from the slave host to the master host, and it's sent over the management network. The master sends heartbeats to the slave hosts. And if a slave host does not respond, the master must make the decision. Is the problem a crashed host, or is it a network connectivity failure? To make the decision whether or not the problem is a network connectivity failure, it uses data store heartbeats. The data store network, which as you know is the storage area network, can act as a backup for the management network. So if the master host can receive heartbeats from the data store network, but it can't receive heartbeats over the management network, that indicates that the host is still running, but that there is a cabling problem. Now, if it can't get a heartbeat from either, that means either it's a failed host or an isolated host. What's an isolated host? An isolated host is when the master does not receive management network heartbeats from the slave ESXi host, and it doesn't read data store network heartbeats. So even if it's up and running, it can't be reached. This is called an isolated host. If there's an isolated host, vSphere starts the virtual machines on another ESXi host. Host isolation events can be minimized through good design. For example, by ensuring that the management network and the data store network are on physically separate networks. And of course, we've already discussed that with the storage area network. And also by having redundant data paths, and we've already discussed that with network interface card teaming. Let's now look at virtual machine fault tolerance. With virtual machine fault tolerance, you have one virtual machine running on one ESXi host, and then you have another identical virtual machine running on a second ESXi host, and they are running in sync. If either one dies, that's okay. The other one is right there. Now this sounds a lot like what we just discussed, high availability. In either case, You got two virtual machines. If one dies, the second one takes over. What's the difference? The difference is, with high availability, if an ESXi host crashes, then the virtual machine has to be pulled off of the disk array and loaded into the memory of another ESXi host, and that might take a few minutes. But with fault tolerance, the second virtual machine has already been loaded into the memory of the second ESXi host, so it's available immediately. Very similar. But with high availability, there's a delay of seconds or a couple minutes, but with fault tolerance, the second server is available immediately. Two virtual machines are in sync. If one dies, the other one is right there. Now, what keeps them synced up is what we call lockstep technology, and this synchronizes the RAM of the first virtual machine with the RAM of the second virtual machine. So if either one crashes, the other one is there. With fault tolerance, with high availability, the downtime can be seconds or minutes. But with fault tolerance, the downtime is 0. Let's look at fault tolerance in action. This is the primary virtual machine, and it is a replica, a mirror copy, is running, and it is called the secondary virtual machine. And lockstep technology is the software that replicates the first virtual machine to the second virtual machine. If the first virtual machine crashes, then the second virtual machine takes over. Not only that, it becomes the new primary virtual machine, and then a third ESXi host houses the secondary virtual machine, so we still have fault tolerance even though the first one crashed. That's called lockstep. Fault tolerance guidelines ensure that there are enough ESXi hosts for fault tolerant virtual machines. You got a maximum of 4 fault tolerant virtual machines for any single ESXi host. So if you want to have 5 fault tolerant virtual machines, you'll have to get an additional ESXi host. Also, disable BIOS-based power management so the secondary virtual machines will have sufficient CPU resources. To enable fault tolerance, well, we've already done part of it. If you go to the ESXi host, to the cluster, rather, that the hosts are in, right-click on the cluster and select Edit Settings. You can see we already have the checkbox for Turn on vSphere High Availability, and notice that vSphere High Availability must be turned on to use fault tolerance. So that's already taken care of. All we have to do is specify which virtual machine is going to be fault tolerant, which virtual machine is going to be running on 2 ESXi hosts simultaneously. So I will select the accounting server virtual machine, right-click on that, and under fault tolerance, I will select Turn on fault tolerance. Are you sure? And I click on Yes. And now the accounting server will be fault tolerant, running on 2 ESXi hosts at the same time. If one dies, the other one is right there. The way they remain in sync is the lockstep technology, which they also call logging traffic, and that traffic can be so high you might even want to get a separate network just for the logging traffic. Now you already have one network for the production network and a second network for the storage area network. You might even want a third physical network connection to hook the ESXi hosts together solely for the purpose of logging traffic for fault tolerance. Now let's move to Lesson 5, Introduction to Data Store Replication. We've already looked at redundancy of ESXi hosts. Now let's look at redundancy of data stores. With replication, it's similar to disk mirroring, except there is replication between disk arrays in a storage area network. This gives us data store fault tolerance. The first disk array replicates the second disk array. If either one crashes, that's okay. We're covered. The vSphere replication appliance is a piece of software which we install, and you know what an appliance is. It's made up of a virtual machine, of an operating system, and the application. And the application here is the replication software. What the replication software does is it tracks changes sent to the first disk array, and then it writes those changes to the second disk array so they remain in sync. The vSphere replication appliance only replicates changed blocks. It doesn't copy the entire disk array periodically from one disk to the second. It just copies the changes. It's more efficient, and that way it ensures that the disks are always consistent. Replication can occur within a site or between sites. Two examples. We could have replication from remote offices which replicate into the main office, or we could do it the other way around. We could have replication from the main data center, and it could replicate to disk arrays at remote offices. Replication is similar to disk mirroring, except it's replication of data between disk arrays in the storage area network, and the whole purpose is for data store fault tolerance. In this module, we discussed vSphere high availability, and we saw that it protected against failed hosts, failed virtual machines, and failed applications. How did it know that a virtual machine crashed or an ESXi host crashed? Because it ceased to receive heartbeats. Virtual machine fault tolerance is very similar, except the two virtual machines are running in sync. And if the first one crashes, the second virtual machine is available immediately. And replication provides replication of data between disk arrays to provide a fault-tolerant data store. This concludes Module 11, High Availability and Fault Tolerance. Thank you very much, and have a nice day.